Hello students, welcome to EPG Pathshala. I am Dr. Renu Tyagi from Department of Anthropology, University of Delhi. Today we are going to discuss the module titled Hydraulic Civilization from the paper Ecological Anthropology, Cultural and Biological Dimensions. The learning objectives of the module are: number 1, to understand about the hydraulic civilization; number 2, to identify the features of the hydraulic societies; number 3, to enable the students to know about the contribution of the hydraulic societies. According to the Encyclopedia Britannica, it is the theory by Carl Wittfogel that hydraulic civilization means any culture having an agricultural system that is dependent upon large scale government managed waterworks, productive and protective. The theory believed that whenever irrigation required substantial control, government representatives monopolized political power and dominated the economy, resulting in an absolutist managerial state. The officials were identified then with the dominant power and other center of power. This topic discusses on how the theory of the hydraulic civilization influenced the growth of early civilization and how it generated the idea of cultural development in the ancient times. Figure 1 depicts the beginning of the civilization at the source of a water body. German-American historian Carl August Wittfogel, in his book Oriental Disposition, has written that civilization with agriculture depended upon large-scale waterworks for irrigation and flood control were called the hydraulic civilization. According to his observations, wherever irrigation required substantial and centralized control, the government representative monopolized the political power and dominated the economy, resulted in an absolute managerial state. Thus, there was a close identification of these officials with the dominant religion and an atrophy of other centers of power. The forced labor for irrigation projects was directed by the bureaucratic network of the ruling government. According to Wittfogel, neither too little nor too much water leads necessarily to centralized water control and governmental disposition. He says an economy must be neither too primitive nor too advanced to institute in a water deficient landscape a specific hydraulic order of life. He relates this order further, saying it has its own type of division of labor and necessitate the cooperation on a large scale. Irrigation and flood control as well as roads, defense system, palaces and tombs are government comprises demanding commanded labor forces, or labor is not slave labor, but it is less free than the wage labor. The power of the hydraulic state is greater than the power of the government in free enterprise system. It extends over society as a whole by limiting property rights, by taxation and confiscation, and a variety of the managerial measures that prevents the non-governmental forces of society from crystallizing into independent bodies strong enough to counterbalance and control the political machine. Often philanthropic in form, hydraulic despotism is oppressive in content and its total power spells total corruption, total terror, total submission and total loneliness. The difference between hydraulic and non-hydraulic societies then one between the despotic and less despotic states, between concentrated and less concentrated power monopolies, and choosing the lesser evil. Wittfogel prefers the latter to the former. Among these hydraulic civilization, Wittfogel lists ancient Egypt, Mesopotamia, India, China, pre-Columbian, Mexico and Peru. Now let us see what is hydraulic hypothesis. Wittfogel has emphasized that large scale irrigation result in the authoritative political patterns. He posits that in the hydraulic states, one finds such authoritative political patterns as an agro-managerial despotism and a monopoly bureaucracy. The combined work of the Wittfogel and Stewart have postulated that large-scale irrigation requires centralized coordination and direction of efforts, which in turn leads to a greater political integration. Thus, they propose that irrigation is a major cause of the eruption of the centralized political authority and supra-community political organization, and these causes led to the development of the early civilization. The elements of Wittfogel and Stewart argument focuses on the nature of the task in large-scale irrigation. Water courses must have dams, canals must be dug out and maintained periodically. Since it is a scarce commodity, it is to be controlled, cooperative, and activity of the several communities is required, since they will be linked by the same network of the ditches and canal. According to Wittfogel, if irrigation farming depends on the effective handling of a major supply of water, its tendency to gather in bulk becomes institutionally decisive. A large quantity of the water can be channeled and kept within the boundaries only by the use of the mass labor, and this mass labor must be coordinated, disciplined and controlled. Thus, a number of farmers eager to conquer arid lowland and plains are forced to involve the organizational devices which, on the basis of a pre-machine technology, offer one chance of the success. They must work in cooperation with their fellows and subordinates themselves to a directing authority. The institution of the hydraulic society differs structurally and apparently with regard to the hydraulic and managerial density. It also differs with the respect to the cooperative complexity, the quality and dimensions of the active productiveness, private property and private property based enterprise. Figure 2 illustrates the hydraulic hypothesis as emphasized by Carl Wittfogel. Now let us understand the natural setting of hydraulic society. Historical conditions being equal, many factors differentiated agrarian life prior to the industrial age, but none corresponded in institutional importance. The appealing confutation offered by arid areas having accessible sources of water supply other than the on-the-spot rainfall. Under the defined conditions of pre-industrial agriculture, the natural configuration precisely affected men's behavior as a provider of food and organizer of human relations. Of all the tasks promulgated by the natural environment, it was the task given by a dubious water situation that keyed up men to develop hydraulic method of social control. Several natural factors essential to farming, that is, water is not the only natural factor fundamental for the successful crop raising. Anyone wishing to farm must have at their disposal useful plants arable soil, ample humidity, appropriate temperature and a suitable relief of land. All these elements are equally important. The deficit of any one of them demolishes the agronomic value of all the others. Cultivation remains futile unless human actions can recoup for the total scarcity of any essential factor. Now, let us see some essential factor defy the compensating actions. Others respond more readily. The cogency of the means setting actions depends on the case with which a flawed natural factor can be replaced. Some factor must be considered constant because under existing technological conditions, they are all practical purposes beyond man's control. Humans can manipulate or it necessarily can change them. The specific qualities of the water can be understood with the fact that compared to the other essential natural prerequisite of the agriculture, water is specific. In contrast to the temperature and surface, water is neither too remote nor too massive to permit manipulation by human. Figure 3 depicts the role of prerequisite in the natural setting of hydraulic civilization. Now, let us understand some of the characteristics of hydraulic economy. They are: number 1, there is a division of labor in hydraulic agriculture between protective and preparatory operations. In large scale preparatory operations, the combined agricultural activities of an irrigation farmer are comparable to that of the rainfall farmer, but the operations of the irrigation farmer include on the spot ditching, damming and watering that are absent in the operations of the rainfall farmer. In pre-industrial civilization, man gathered, stored and controlled water on a large scale, showing the distinct division between the preparation and ultimate labor characteristics of all hydraulic agriculture. On the other hand, in large scale protective operations, flood controlled by the labor was the major objective. The community resort to the preparatory labor to safeguard the producing use of the water to safeguard its crop from periodic and excessive inundations. Next is cooperation. One of the important factor is cooperation in dimensions. When a hydraulic society covers only a single locality, all adult male members were to be assigned to one or few communal work team. The changing needs and instances modify the size of the mobilized workforce. In hydraulic culture, having several independent sources of water supply, the task of controlling the moisture is performed by varying number of separate work teams. Next is the integration. Orderly cooperation requires planned integration. Even in the simplest operations, it necessitates the substantial integrative action. In their more expensive diversities, they involve extensive and complex organizational planning. The next one is leadership. All teamwork requires a team leader, and the work of the large integrated teams require on-call leaders and disciplinaries as well as the overall organizers and planners. The next required is the political leadership. The collective management of the waterworks involves an organization web which covers either the whole or at least the dynamic core of the country's population. In consequences, those who control this network are uniquely prepared to wield supreme political power. No matter whether traditionally non-hydraulic leaders initiated or seized the incipient hydraulic apparatus, or whether the masters of this apparatus became the motive force behind all important public functions. there can be no doubt that in all these cases, the resultant regime was decisively shaped by the leadership and social control required by the hydraulic agriculture. Now, let us understand the heavy water work and the heavy industry. With regard to the operational form, hydraulic agriculture exhibits important similarities to heavy industry. Both type of economic activities are preparatory to the ultimate process of production. Heavy waterworks feed the ultimate agrarian producer one crucial auxiliary material. Heavy industry provides auxiliary and raw material for various kinds, including tools for finishing and heavy industry. Heavy waterworks fulfill important protective function for the country at large. The protective installations of industry do not provide. The heavy waterworks of the hydraulic agriculture are directed essentially by the government. The government also engage in certain other large enterprises which in varying combinations supplements the agro-hydraulic economic proper. Calendar making and astronomy, important functions of the hydraulic regime. Among the intellectual functions fulfilled by the leaders of the agro-hydraulic activities, some are only indirectly connected with the organization of men and material, but the relation is highly significant nevertheless. Timekeeping and calendar making are essential for the success of all hydraulic economies, and under special conditions, special operations of the measuring and calculating may be urgently needed. As a rule, the operation of the timekeeping and scientific measuring and counting were performed by the official dignitaries or by the priestly specialists attached to the hydraulic regime. Wrapped in the cloak of magic and astrology and immured with secrecy, these operations became the means for both improving hydraulic production and supporting the superior power of the hydraulic leaders. Now, let us see the further construction activities customary in hydraulic societies. With regard to the hydraulic and non-hydraulic constructions, they can be categorized as number 1, hydraulic works, which is productive installations, canals, aqueducts, reservoirs, sluices and dikes for the purpose of irrigation. Next is protective installations, drainage, canal and dikes for the flood control. The next is aqueducts providing the drinking water, and next is the navigation canal. Now, let us see the non-hydraulic work. The work of the defense and communication, wall and other structure of the defense. Highways comes under this category. Edifice serving the public and personal need of the secular and religious masters of the hydraulic societies, that is palaces and capital cities, tombs and temples. Table 1 indicates the management related aspects of the hydraulic state both in agriculture and industry in 4 institutional conformations. Now, let us understand with the examples of early hydraulic states. The Egyptians and the Mesopotamians about 6000 to 7000 years ago are the farming villages of Near East and Middle East became urban center. During the Neolithic age, that is 5700 to 2800 BC, the first successful effort to control the flow of water were driven by the agricultural need, that is irrigation, and were implemented in Mesopotamia and Egypt. The ancient Mesopotamian valley lacked good drainage and experienced mainly floods. The consequences was that the ancient Mesopotamian had to build canals to divert water from the river to develop their canal irrigated agriculture. The large-scale diversion of the water by humans probably had its origin in ancient Mesopotamia. Other hydraulic technologies of the Mesopotamian included the water tunnels, horse or donkey powered chain lifts, and at least one major irrigation diversion dam. The ancient diversion dam, the Nimrud Dam, was built across the Tiger River hills about 180 km upstream from the Baghdad. The river water was diverted through the Narvan Canal to irrigate an area extended over 100 km to the present time of Bakuba. At Bakuba, this canal joined with the Diyala river to supplement its discharge for the 200 km reach of the Diyala in the ancient course from Bakuba to the Tigris river at the modern day city of Kut. The ancient diversion dams and the canal not only irrigated the desert area but also transferred the water from one river to another. Now, let us see the artificial basin irrigation, which is established in Egypt by the first dynasty, that is 3100 BC, included deliberate flooding and draining using the sluice gates and uncontained water by longitudinal and transverse dikes. This form consisted of a network of earthen banks, some parallel to the river and some perpendicular to the river, that formed basin of various sizes. Flood waters were diverted into the basin where the water was allowed to saturate the soil with the remaining water drained off to a down gradient basin or to a canal. After the draining process was completed in a basin, crops were planted. Basins were supplied with the water by feeder canals. The bed level of the feeder canal was midway between low Nile and ground level, with a natural downstream slope less than the slope of the Nile. Dikes, that is levees, separated the basin with the control machinery regulatory on the earthen embankment to control the flow of water into the basin. The basin were very level as a result of the water laden alluvium that deposited on the basin. During the years of the low flow in the Nile, basin were drained into the next downstream basin instead of the back to the river. Figure 4 provides the glimpse of some ancient hydraulic civilization located near the prominent rivers. According to the Carl Butzer, in early hydraulic civilization in Egypt, the most of the settlement sites of the 10 to 20 millennium ago were already situated on the immediate banks of the river Nile. The desert edge settlement or the cemeteries have frequently been misinterpreted as step in a comparatively late agricultural colonization of the valley. In fact, drainage was the general prerequisite to cultivation, and artificial irrigation was an option desirable only to increase average and equalize year to year productivity of the naturally irrigated flood basin. The artificial irrigation, including the deliberate flooding and draining by the sluice gates and water contained by the longitudinal and transverse dikes, was established in the first dynasty. Controlled irrigation was easiest among the smaller flood basins of southern Upper Egypt and further north in the eastern banks. In these areas, crops steadily increased at the expense of the pastoral activities and the remaining tract of the natural vegetation. Figure 5 depicts thematically the rise of hydraulic civilization and their impact. Now, let us summarize the module. So far we have understood that according to the Wittfogel and Stewart, Water courses must have dam, canals must be digged and maintained periodically as it is a scarce commodity. It is to be distributed. Cooperative activities of several communities is desired, since they will be linked by the same network of the ditches and canals. A number of farmers eager to conquer arid lowland and plains are forced to invoke the organizational devices which on the basis of a pre-machine technology offer one chance of success, and they are compelled to work in cooperation with their fellows and subordinate themselves to a directing authority. The institution of hydraulic society differs structurally and apparently with regard to the hydraulic and managerial density. It also differs with respect to corrective complexity, the quality and the dimension of the active, that is productive, private property and private property based enterprises. Many factors differentiated agrarian life prior to the industrial age, but none correspond in institutional importance. The Egyptian and the Mesopotamians are the examples of early hydraulic states. Water is not the only natural factor fundamental for the successful crop raising. Anyone wishing to farm must have at their disposal the useful plants, arable soil, ample humidity, appropriate temperature and a suitable land area. Therefore, all these elements are equally important. The deficiency of any one of them demolishes the agronomic value of all the others. Cultivation remains futile unless human actions can recoup for a total scarcity of any essential factor. The characteristics of the hydraulic economy includes division of labor in hydraulic agriculture, which is further subdivided into protective and preparatory operations. Separated from the farming proper and comprises of the large scale preparatory operations and the large scale protective operations. Another important characteristics of the cooperation, and it includes, is dimensions, integration, leadership or political leadership. Thank you.